Hey, pre-AP Algebra 2, let's do lesson 9. We're going to learn about radicals and conjugates. Sounds pretty radical. Anyhow, here we go. Hey, let's look at some opening exercises. Let's just think about it real quickly. I have an illustration, essentially, of the distributive properties for I. Our first example there. What do you think? Is it true for all A and B that are greater than 0? In other words, right? Let's assume A equals 2 and B equals, I don't know, 3. And let's see if each of these work out. So here, is it true that 2 times 2 plus 3 is the same thing as 2 times 2 plus 2 times 3? That's what we're being asked for. And, indeed, that is true, right? Because this is 2 times 5, or 10. And over here, we have 4 plus 6. Or on the right-hand side, we have 4 plus 6, which is 10. Awesome. How about this one? Again, assuming that A is 2 and B is 3. So 2 plus 3 over 2. Is that the same thing as 2 divided by 2 plus 3 divided by 2? Well, it looks like I have 5 halves on the left and 5 halves on the right. So that's true. So now let's look at this last thing. It looks like we have a radical. We have the square root of A plus B equal to the square root of A plus the square root of B. Let's see if these two things are equivalent. So again, if we assume that A is 2 and B is 3, then this is 2 plus 3. And this is the square root of 2 plus the square root of 3. So we have square root 5. Is the square root of 5 equal to the square root of 2 plus the square root of 3? We can put that bad boy in your calculator and figure this out. Alright, so we calculate the square root of 5. That's approximately, so the square root of 5 is approximately 2.236. And the square root of 2 plus the square root of 3 is approximately, and this is going to be approximately, right, the square root of 2 plus the square root of 3 is approximately 3.146. So let's turn out the same. So we got to be careful with our radicals, right? It is the case, though, that the square root of A times B is equal to the square root of A times the square root of B. And we're going to be able to use that property quite a bit. As a matter of fact, it's the key to simplifying radicals. So let's go ahead and simplify some radicals. All right, so I'm going to rewrite these in different ways. 50, it turns out, what I want to do is I want to say, hey, is 50 divisible by something that has a perfect square? And remember, perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and so on. We can keep going for a very long time. So indeed, 50 is divisible by one of those. 25, and it's 25 times 2. So I'm going to rewrite these by simplifying the radical, right? You learned how to do that in geometry. So this is going to be 9 times 2, and the square root of 8 is 4 times 2. All right. Remember, when we're simplifying these radicals, we're going to take the square root out. So the square root of 25 is 5. That's going to come out of my radical. Square root of 9 is 3. That's going to come out of my radical. And the square root of 4 is 2. That also comes out of my radical. Now, imagine that this is a lot like 5x minus 3x plus 2x, right? What would we get if we combine all of those things? Well, you would get 4x, right? We're going to do the same thing. It's almost like that square root of 2 is acting like the x. So we're going to be combining like terms. So in other words, we're going to wind up with 4 root 2. Okay? 5 minus 3 plus 2 root 2's, right? It's like we have 4 root 2's there. So let's go ahead and do this next one. It's a little different. And for this one, not only am I going to use the property where we can multiply underneath our radical or take factors out, I also want to use this property, right? That if I have the square root of a over b, that's equal to the square root, or any root, right, of a over the root of b, right? It could actually be any nth root, as long as n is the same. All right, so I'm going to rewrite this. Square root of 1/4 is the square root of 1 over the square root of 4. I'm going to write this as the square root of 9 over the square root of 4. Minus, and now I'm going to go ahead and simplify this radical. So this is 9 times 5, right? Fantastic. A, the square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. Square root of 4 is 2. And the square root of 9, that's going to come right out the front. It's 3, so this is 3 root 5. I can combine these two. And that will be, that'll come out to 2, right? And that's all I can combine. That's my final answer. Hey, let's do this next one. In this case, I'm going to distribute, right? So I'll have the square root of 2 times the square root of 3. So I can write that as the square root of 2 times 3. And then I'll do the square root of 2 times negative square root of 2. So that is going to be the square root of 2 times 2. So I have the square root of 6 minus the square root of 4. Can I simplify that square root of 6? It's not divisible by a perfect square, so I can't. But the square root of 4, I can do that. So that's how we would simplify that way. Okay, moving right along. Let's simplify these. All right, here we go. So again, I'm going to write this as the square root of 3 divided by the square root of 8. There is a rule in mathematics that we don't like to have a radical in our denominator, right? It's not wrong. It's just it's impolite. You know, it's not the most correct way to do it, right? You know, it's one of those things. It's like if I'm over at my friend's house and I open the fridge and I eat a bunch of food, right? It's not the nicest thing to do, but it does happen. But we're going to avoid it, right? So how are we going to get rid of that square root of 8? Oh no, don't just erase it. Let it be back. What I'm going to do is I'm going to do what's called rationalizing my denominator. How do I rationalize my denominator? I multiply it by a very special number 1. Okay? So then what do I have? I have the square root of 3 times 8 here, right? And then over here I have the square root of 8 times 8. But hey, isn't that the same thing as the square root of 64? It is! So then I'll call this the square root of 24 divided by 8. Alright, and that's again because this is the same thing as the square root of 64, which is 8. Hey, can I simplify that square root of 24? I sure can. Well, is it divisible by something that has a perfect square? No, it's not. No, so we're good to go. Right? Oh, it's divisible by 4. How about 4 times 6? So here we go. So the square root of 4 is 2. The 6 cannot be simplified. I'm not lying to you about that. And then 2 over 8 is... 1/4. There we go. So now we've simplified this thing. It's like sorcery. What type of mathematical sorcery are you engaged in? So I gotta rationalize this. What I'm gonna write this as the cube root. Now we're working with cube root, right? It's a little different than a square root because we're gonna be looking for perfect cubes instead. I need to rationalize my denominator. How am I going to do that? Again, I'm going to use this very clever number 1. All right, here it is. Okay. So over here we have the cube root of 5 times 32. And over here, I'm just going to say, hey, the cube root of 32 times the cube root of 32 is just 32. All right? Now I have to get out my handy-dandy calculator. I found it. All right. 5 times 32. So I have the cube root of 160 divided by 32. Now I need to say to myself, I'll say what? I'm sorry. Is 160 divisible by something that has that's a perfect cube, right? So in other words, perfect cubes would be like 8, 27, 64, and so on, right? Let's look. 160. It's definitely divisible by 8, right? That's the easy one. And that's the one we want. Perfect. Fantastic. So I could say that this is the cube root of 8 times 20 Because I know 20 is not divisible by something that's a perfect cube, right? Okay. So this is going to be, what's the cube root of 8? Well, since 2 times 2 times 2 is 8, then the cube root of 8 is 2. So this is 2. Cube root 20 divided by 32, which is the cube root of 20 divided by 16. And there it is. Hey, here's an interesting one. A little different. We put some variables in this. What I'm going to do is go ahead and write this as the cube root of 16, right? I'm going to break it up because we're using multiplication, so I'm allowed to break it up as if it got... Okay, so I'm going to simplify these two things separately. So I'm going to break this 16...
It's not recording. I'm sorry.
All right. I'm going to call this the cube root of 8 times 2, right? Because 8 has a cube root. And then that's going to be times. And I'm going to do something real tricky here. X cubed times x squared. Isn't it true that that's the same thing as x to the 5th? Okay. So I'm going to pull this 2 out because the cube root of 8 is 2, so that's going to come outside. And then what is the cube root of x cubed? It's just going to be x. Oh, and I forgot my cube root here. So that is going to be x squared. Now we can simplify this just a little bit more. We can put it back together. So this becomes 2x times the cube root of 2x squared. And we did it! Right, here we go. That's Jacob Ecker, by the way.
My sister's gonna hear this.
All right. Hey, let's go ahead and multiply these two things. First, let's do this one. So this is the square root of 3 plus the square root of 2 times the square root of 3 plus the square root of 2. All right, so square root of 3 times the square root of 3 is 3, right? That times that. The square root of 3 times the square root of 2 is going to be positive root 3 times 2. Then I do this guy right here. That's going to be positive root 2 times 3. And then when I multiply these two, right, the square root of 2 times the square root of 2 is just 2. Okay, I'm going to actually just go ahead and take an extra step on this for y'all. Hey, in the middle I have a square root of 6 plus square root of 6. Now, I essentially have 2 square root 6, right? If I have a square root 6, you give me one more square root 6, then I have 2 square root 6s. Hey, I can go one more step further and call that 5 plus 2 square root 6. And there we go, we've done that one. Now let's go ahead and do this bottom one, and let's see what the difference is. All right, square root of 3 times the square root of 3 is going to be 3. And the square root of 3 times negative square root 2 is negative, let's call that root 6, okay, right away. This one's going to be positive root 6. This one is negative 2. Hey, what is negative root 6 minus root 6? 0. Sorry if I scared you. Ooh, whoa, that's warm. That's cray cray. All right, here we go. So why did we do that? There's going to be a point in time where in order to rationalize our denominator, we're going to have to multiply it by the conjugate. All right? So what does that mean? It means I have the same thing, right? So the square root of 5 minus root 3, right, is the conjugate of root 5 plus 3. All I do is I take the same two terms of my binomial, but I change the sign in between. In other words, I change the value of that second term. If I do that, I wind up getting radicals to go away. If I multiply by my conjugate, the whole purpose of that is to get rid of radicals. Let's see if that happens right here. So when I multiply root 5 times root 5, I get 5. When I multiply root 5 times negative root 3, I get negative root 15. When I multiply root 3 times root 5, I get positive root 15. And then root 3 times negative root 3 is negative 3. And yeah, I did it, right? Because negative root 15 plus root 15 is 0. And then actually 5 minus 3 winds up being 2. So I can multiply it by this thing called the conjugate, right, where it's just changing the sign in between. And that gets rid of my radical in my expression. Let's do the same thing with this one. 7 times 7 is 49. 7 times root 2 is 7 root 2. Root 2 times 7 is 7 root 2. And root 2 times negative root 2 gives me negative 2. Hey, that 7 root 2 and that negative 7 root 2 are going to cancel. So I really just wind up with 49 minus 2, which is 47. Should we do it again? Let's do it again. It was so much fun the first time. Here we go. Root 5 times root 5 is 5. And then I have a positive 2. Oh, sorry, let's start with a negative root 2 root 5. Negative 2 root 5, right? And how did I get that? I multiplied this one times that one. That's negative 2 root 5. I'm going to now multiply, right? I did that one. Now let's go ahead and do this one. Positive 2 root 5. And this gives me negative 4. So my answer is 1. Because the negative 2 root 5 and the positive 2 root 5 will cancel. Alright, so now if I'm being asked to write, as I am in example 3, to write this in the simplest radical form, what it means is, hey, you got to rationalize that denominator, alright? It's not cool. It's like Renato coming and eating all the food in my fridge. Yeah, dude. So, it's just not polite. So what I'm going to do is I'm going to multiply again by a special number 1. But in that number 1 is contained the conjugate. So I'm going to multiply this by the conjugate. And if I do it in such a way that it's a special number 1 like this, right? Isn't that just 1? It's 1. It's just a big, old, weird number 1, right?
How many times do you want?
All right, let's go ahead and multiply this out, okay? So essentially, what I have here is, I'm going to write this in between step now, because it's important for you to see. All right, so that's what that is when I multiply that out. And now we're going to distribute. So root 3 times 5 is 5 root 3. Root 3 times 2 root 3 is going to be essentially 2 times root 3 times root 3. I'm just going to write it out like that for now. Let's go ahead and do our denominator. 5 times 5 is 25. And 5 times 2 root 3 is going to be 10 root 3. Right? We're going to multiply those coefficients just like we did if they were coefficients of x. Now I'll multiply negative 2 root 3 times 5, which is going to be negative 10 root 3. And I'll multiply negative 2 root 3 times negative 2 root 3, which is going to be essentially negative 2 times negative 2, which is negative 4 times root 3 times root 3. Right? Let's simplify all this stuff. If I have 5 root 3 plus 2 root 3, I get 7 root 3s. Jumped the gun. How about we call this 5 root 3 times, well, we have root 3 times root 3, which is just root 3, right? Which is just 3. So this is actually plus 2 times, I'm going to write it like this. Just to take the extra step. All right, here I have 25. The 10 root 3 minus 10 root 3 cancels. And over here I have 4 times root 9. All right. This is going to be 5 root 3. And then the square root of 9 is 3. So I have 2 times 3 there, which is 6. And the same thing's going to happen down here. I have 25 minus, well, 4 times root 9 or 4 times 3 is 12. Almost done. So I have 5 root 3 plus 6 divided by 25 minus 12 is 13. Yay, we did it! That was lesson 9. Thanks for watching, everyone. Bye!